Section 2.5 is limits involving infinity. This is a pretty brief unit with just some conceptual things, so let's get started. We're looking here at two things. One, what happens to the limit as x approaches infinity, and we could do plus or minus infinity here, positive or negative infinity. Or we're looking at what if the limit approaches infinity. Okay, so first of all, let's take a look at the picture on page 53. And we're going to be looking at the graph here. And you can see that there are some asymptotes involved. One at y equals 3, and one at x equals 2. And our graph is a hyperbola. Looks like this. So let's first look at the limit of this function as x approaches 2 from the left. Remember, that means starting here at the negative side of the graph and coming towards the right. So as we approach 2 and I follow along the graph in this direction, you can see that we are heading towards negative infinity. The graph is going to continue. The closer I get to 2, the closer the y value, or the limit, is to negative infinity. Looking at the limit of f of x as x approaches 2 from the right, now we're coming along the graph from the positive side, or from the right, and you can see that what happens as I get closer to 2 is that I approach positive infinity. Okay. The next thing we want to look at is what happens here as the limit as x, and this is the case where the limit is approaching infinity, the value of the limit of f of x as x approaches positive infinity. So again, now we're taking the x value and we're going towards positive infinity, and you can see that the graph, as it moves out here, gets closer and closer to 3. The other direction, taking a look at the limit of f of x as x approaches negative infinity, coming towards the left, so going this direction or this direction on the graph, we also approach 3. You can see that these limits that involve infinity, whether the limit itself approaches infinity or whether we are going towards infinity on the x-axis, all involves asymptotes. If you take a look at the box on page 54, there are quite a few lengthy definitions there. I'd like you to just take the time to read through those slowly, trying to understand using the terminology. We will be going over these in class. It's not necessary for you to write these down in your notes. But take a look at the bottom of page 54 where it says definitions. And this is what we just talked about on the last screen, that the limit of f of x as x approaches infinity, if that is some value L, then L is a horizontal asymptote. And that was the example where we were coming out here towards infinity and our graph approached some horizontal asymptote L. The converse is that the limit of f of x as x approaches c, and we're saying absolute value here because we don't want to write two positive or negatives, but as x approaches c is infinity, then x equals c is a vertical asymptote. Here, y equals L is your horizontal asymptote, and x equals c is your vertical asymptote. Take a moment to look at example 2 on page 56. Cover up the solutions at the bottom and see if you can determine these limits from the graph. Okay, so looking at the top of example 2, our first one asks you to find the limit as x approaches infinity of f of x. So as you move towards the right on this graph, you can see that the numbers, or the graph, is getting closer and closer to this asymptote of 4. The next one, moving across, the limit of f of x as x approaches 3 from the left. Coming from the left, the graph is moving up this way, and it comes towards 6. I'm going to let you finish looking at these on your own. It's a little difficult without the graph in front of me here to show you, but I think you'll get the idea, and again, we'll look at this example together in class. At the bottom is just some definitions for you: undefined, infinite, and determinant. Please read through that as well, and we will talk further if you're confused by any of that terminology. Really not much notes to take on this section, and that's it for 2.5.